So methods and inheritance. So things that you can do is obviously inherit a method, and what happens then is that a subclass accepts the superclass implementation of the method. For example, the getName method within person is inherited all the way down through all the subclasses from university person to student. Everybody inherits that method. Another thing you can do, obviously, when you inherit it, you can add your own methods to your subclasses, so you're not prevented from doing that. So basically, we're going from the more general behavior at the top of the class hierarchy to the more specialized behavior. And if you want more specialized behavior, presumably you'll have more parameters and you'll need to add more methods to do that. And an example of that we had was the getStage method within the student class. So you don't have that in the classes above because it doesn't make sense to have it above. As we said, you can override methods and you can overload methods. Okay. So, so this is a recap of references within inheritance. So we've done some examples on this already. So reference assignment, when you do something like this, left-hand side is equal to right-hand side. It means that the left-hand side reference refers to the same object as the right-hand side. Essentially, what we're doing, this is pointing to a certain address, 1, 2, 3, 4, and now this also points to 1, 2, 3, 4. So they're both now pointing to the same object. So that's what we mean when we say that references are passed by value. By value, we mean the value address of the object. Okay. So that's the value that's being passed. It's the address of the object that's being passed from one reference to another reference. Yeah, method calls. So we did a quiz which showed that method calls combine declaration and assignment. So within the quiz that we did, there was a method called do something, and you passed a parameter to it. And when you pass that parameter, you combine in both declaration and the assignment. You're saying that this reference is equal to the reference that's being passed to it. So now they both point to the same object. They both have the same address. So both the reference and the object it refers to have a type, which must be compatible. So, so for example, if you want to do something like this, the left-hand side reference is an inclusive supertype of the right-hand side. So you can say, for example, so if you've got person P and you've got student S, then you can say P is equal to S because P is a person and P is the supertype of S. So you can do it that way. So the left-hand side needs to be inclusive of the right-hand side. If you have it the other way around, you can also say, so the right-hand side can be an inclusive type of the left-hand side, but then you need to do casting, and you need to know what's contained in the object on the right-hand side. So I'll show you an example in a second. So the right-hand side must be cast by type conversion down to its left-hand side subclass. So you need to, if you want to say that S is equal to P, that the student parameter is equal to P, you need to be sure that P contains a student and that it doesn't contain a lecturer, for example. So otherwise you'll end up with a runtime error. The right-hand side must be cast by type conversion down to its left-hand side subclass if you have a situation like this. And therefore you need to be sure that P here contains a lecturer. You're able to do that. And the way you check for that is you use the instance of to check that casting will succeed. So you need to check what is contained within P. Is it an instance of lecturer or not? To be able to do that. So, so the type of the reference determines method visibility. Okay, so if the reference type, so you need to remember that there's a difference between the reference type and the object type. The reference type is what determines method visibility. Okay, so if you're saying person P is equal to new student, then if you do then P dot calling a method, you can only call methods that exist within the person class. The type of the referenced object determines method execution. So if there's the same method within the person and the student, and you say p.getStage, p.getAge, then the one that's in the object, the method that's within the object type is the one that gets executed. So that gets decided at runtime. Yeah. So because you have all this flexibility, we say that object variables in Java are polymorphic. Polymorphism is a Greek word. Poly means many, morphic means shape, yeah, many shapes. So overriding and overloading are two types of polymorphism, where you have the same method doing different things depending on how you call it. So with overriding the methods, obviously you have the same method within several classes, and they each do something slightly different. And overriding and overloading is the same as well. Same method with different parameter types and does different things. Yeah, and objects themselves, object variables can hold objects of more than one type. So, for example, the person P, you can say is equal to new student, it's equal to new lecturer, you can say it's equal to new university person, etc. So because you can do all this, you've got polymorphism there. This object type of type person can hold lots of types of different objects, as long as those objects inherit subtypes of P. So that's what we mean by polymorphism, and it's a very, very powerful property. Yeah, so they can hold objects of the declared type or of subtype of the declared type. So that's a powerful thing. So this is just an example looking at assignment. So as I said, so let's say you've got a lecturer, an object of type lecturer is equal to new lecturer, and okay, one thing that you can do is person P is equal to L, because P is the supertype of L. Therefore, you can do assignments from subtype to a supertype. So that's no problem at all. But you can't do this directly unless you know what exists in P, because P could be a university person, it could be a lecturer, it could be a student. We don't know what's in there. So you need to check first. So you say if P is an instance of lecturer, okay, and then and only then L is equal to P casted down to lecturer. So always do this check if you want to cast, if you want to do this. And here's another example. So vehicle V, you've got car C is equal to new car. So assuming that, so vehicle is the supertype and car is the subtype, obviously. So you can do V is equal to C, whereas you can't do C is equal to V. That will give you a runtime, a compile time error. Your program just won't run. So you have to cast. You need to first of all check what's in V. You need to check, is V an instance of car? Okay, like we did here. So here we did if P is instance of lecturer. So here you need to do if V is instance of car, then C is equal to V casted down to car.